Now guys, it's not gonna be a normal like, hey, what are all our questions? Let's get to the board, because we just frankly don't have time for that with everything coming up. Because we have to get through chapter 9b, which we only have one more section left. Take a test on chapter 9b and do chapter 10a. Don't have to do chapter 10b. It's not on the AP. Don't have to worry about it. But chapter 10a we do have to do, and we have to have a test on it before spring break and any extra why you guys might be gone early things or field trip days. Now, nice thing is we're all seniors, so don't have to worry about like juniors and sophomores. But things get crazy. Layla.
This is not going to be the Friday before break, is it?
Probably not.
Okay, cool.
Misty, I've been selected as a Congress delegate, and I have no idea what that means.
Yay! I don't really know what to say to that. All right, example number 11. Find a power series that represents ln of 1 minus x. Oh, kiddos, easy. How do we do it? ln of u. Do we have an ln of u power series?
Yes.
Yes. What is the power series? Centered at 0. Nice. It's a Maclaurin. Is there a Maclaurin for ln of u? Oh, come on, cool kids. There is. You got it.
Yeah, it's
What is it?
right in my notes.
I feel an Endeavor quiz coming, and it very well might be on Monday. Why on Monday?
But this one's an
Because it's a Monday.
Because we have a test on
Tuesday?
probably Tuesday. Probably Tuesday.
okay.
Okay.
The positive, the plus is
So we'll start with ln of x.
x plus 1.
What do we got?
Wait, you mean the ln of x plus 1?
Oh, x plus 1. Thank you, thank you, thank you, thank you, thank you. Because it can't be x, because if x started at 0, it wouldn't be possible, right? Because then it would be undefined. Now what?
X minus x squared over 2 plus x to the third over 3 minus x to the fourth over 4 plus etc.
Right? No, I'm wrong. What's wrong with my nth term formula?
Plus 1.
Plus 1. Because if it's x to the n, it'd be x to the 0. No. Starts with x to the 1. So x to the n plus 1. Sorry, the negative 1 to the n probably should go in the front, but whatever. So how do I do 1 minus x?
Flip it?
Could I plug and chug? What would happen when I plug and chug?
Oh, it gives a hint
Mm-hmm.
to do. Okay, if you integrate, so then
The hint has me approaching it in a totally different way.
Oh.
I kind of started you off in what would theoretically have naturally have been your thought. What would naturally have been your thought? Well, ln of 1 minus x. I need it to be ln of 1 minus x and yet fit ln of x plus 1. Then what could I do? Any ideas? What could my u be?
minus 2x.
Well, but it's not ln of x, see what I mean? I'd have to plug in, I have to make ln of 1 minus x fit ln of x plus 1.
You can make 1. Oh, it could become
Plus minus x. A negative x.
It could be 1 plus, x minus 1. It could be like x minus 1.
But what would be the problem with that one? I'd have 1 plus x minus 1. I'd really just have x,
Minus
so I wouldn't be able to
2.
use it. Ooh,
I mean,
could I do that?
plus, yeah, minus
We could think of it this way, couldn't we?
Plus.
We need to have u plus 1, right? Because I'm allowed to plug in for x, right? I need to have u plus 1 equal 1 minus x. Isn't that true? So what would my u be?
2.
Negative x.
Uh-huh. So I could just say, oh, okay, so I have negative x. That makes sense, right?
Yes.
Does that make sense, Melissa? because I needed to fit this pattern. So I could plug in a u for x, and u and u and u and u and u and u and u, right? But I needed to equal 1 minus x, so then I end up subtracting by 1, so I end up with u is equal to negative x, so I could plug in a negative x. Hey, isn't this 1 minus x? Got it. So then what? Plug in a negative x, plug in a negative x, plug in a negative x. Ah, stink. What's happening? What's everything? Yeah, just going to be negative x to the n plus 1 all over n plus 1. No alternating because it's all negative, 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 right? How would I find my radius of convergence if I did it old-fashioned way, ignoring the hint? We'll see the hint in a second. Well, is it a geometric series? Times, 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 times. I could do times x, but what about constants? Is it times, times, times constants? No. So I couldn't do geometric series. If I can't do geometric series, what would I have to go back to? Interval of convergence. I have to do the ratio test. Right? So with my ratio test, what would I do? What is the limit? It has to be less than 1 to converge, right? What has to be less than 1?
That, the an plus 1.
The an, well, that's an, right?
Yeah.
So I would have to do the absolute value of, I have negative x to the n plus 1 all over n plus 1, and I would have x to the n plus 1 plus 2 over n plus 2, negative 1. What happens to my negatives because it's absolute value? Just going to be positives with parentheses, right? Is that better? Because n's are always positive. I could put it a different way. Oh, but x's can still be negative though, right? I still have to keep absolute value. Sad times. I'll show you why in a second. Because remember, x's can be lots of different things. So since x's can be lots of different things, I need to keep them in absolute value because they could be negative or positive, which would mess everything up. Okay, how would I do this? I could do n plus 1 all over n plus 2, right? Multiply by the reciprocal. Well, here, this will be easier. Okay, now I can take out the negatives because I have a negative over a negative. Forget the absolute value. I can pull out the n plus 1 over n plus 2 because those don't need to be in absolute value. X to the n plus 2 over x to the n plus 1, what's true there? N plus 2 minus n plus 1, what do I get? Subtract powers, right? What's n plus 2 minus n minus 1? X, right? So I have x less than 1. Remember, for ratio test, I'm taking the limit as n goes to infinity. Limit as n goes to infinity. Limit as n goes to infinity of n plus 1 over n plus 2. That just goes to 1, right? So then I end up with absolute value of x is less than 1, which means x is in between negative 1 and positive 1. But since I did ratio test, what do I still have to test? So I have to test at x equals negative 1, at x equals positive 1, at x equals negative 1. Remember, we have to go all the way back and say, okay, plug in. So at x equals negative 1, I'm talking about the sum from n equals 0 to infinity of plug in negative 1. So I have negative 1 to the n plus 1 all over n plus 1. At x equals positive 1, I'd have positive 1 to the n plus 1 all over n plus 1. Now what? There we go. On the bottom, how could I rewrite the bottom one? He's the easier one. What would he be the same thing as? The negative is in front of everything, right?
Yes.
So since the negative is in front of everything, I could just pull the negative out. What's 1 to any power? What could I do with this one? I could do a direct comparison, maybe? 1 over n diverges and it's going to be greater than, that's not going to help. I could do limit comparison. 1 over m
Yeah.
plus 1, all over 1 over n, the limit would be 1. What's true limit comparison if the limit equals 1?
Both diverge or converge.
That's true, right? If it equals 1, so then 1 over n diverges, so this one's going to diverge. I'm kind of skipping some steps, but I could say diverge by limit.
You said diverge? Yeah.
Because 1 over n diverges, right? So I could say this one diverges.
So we still.
Mm-hmm.
I think it's alternating zeros.
Not the bottom one, because it's negative times 1 to the n plus 1, right?
Oh. Oh yeah.
Does that make sense?
Yeah.
Here's a dilemma though. We made an assumption that we shouldn't make. And what was that? What was the assumption that we shouldn't have made? Technically, we can't say 1 to the infinity is 1. Technically, what would we have to do? I looked back. 1 to the infinity is indeterminate. Aw, man. What can I do instead? First of all, what can I do with m plus 1? Yeah, so I could pull out the negative and I could say 1 to the m plus 1 is equal to 1 to the n times 1 to the 1. What is 1 to the 1? 1, and 1 times whatever just stays the same, right? What test should I use?
Another ratio, or what are, what's
I could do the ratio, or I could do
and
the root,
the root,
the root test. Which one do you guys want to do?
the root one seems, no, never mind, yeah.
We could do ratio or root, either one. I think ratio is probably the more applicable one, usually, right?
Yeah,
So then how do we do ratio test? We already know that.
we just did it.
We just did it. So we have negative. What goes on top? So we go ahead and make it no 1 over 1 to the n. Right? Absolute value for ratio test? Yeah.
Yeah.
Doesn't matter, we pulled negative out anyway, we're just testing this one right now with ratio test. So then we end up with yeah, it's gonna be 1 times 1. So now what?
Write another way.
Find another way. Because remember ratio test, if it equals 1, we know nothing. What about root test?
Wait, what is that?
Would root test still equal 1?
Yeah.
Possibly.
Still equals 1.
Limit again.
I'm gonna use.
But-
Do limit again?
Can
What happened the
we
first time we
just-
did limit?
Can we
We don't know.
can we do whatever the divergence test? And
Wait, did we already do
what
limit
tell?
comparison?
Yeah, we just do.
I know we just did, but why didn't it go away?
'Cause of the
Oh, because
infinity.
1 over n.
Like, you take derivative of b to the n, or b to the n times 1 to the n times ln of 1 over
Steve.
1.
Steve,
Yeah.
could you go back?
Go back where?
For a little?
Oh, zoom out?
Yeah.
0, 1 is 0,
Actually, I don't think it's more negative
Why not?
because ln negative x plus 1, if you take the derivative, it becomes the function we just met. So 1 over 1 minus x.
Oh, you're saying we should go back and use the hint.
Yeah.
We could go back and use the hint. It's way easier. I was trying to see if there actually was a way to solve
So I
as to whether or not at 1 or negative 1. The long story short is they do both diverge, which means that would be our final answer. I was trying to have us review the test as to why they diverge. I mean, the first one would be alternating.
maybe we can only use limit comparison.
Yeah, possibly.
So go back.
Let me do this.
I'm starting from scratch.
We're not starting from scratch. It's called if we just go the way that we're used to, which is, hey, it's an ln. Hey, I have a rule for ln. Hey, I'm just going to use ln. If I didn't use their hint, it would definitely be harder, and we've gotten to the point where we're not exactly sure what to do. So let's go back and see why they gave us the hint.
They like our race. So they gave us a net.
Oh, you don't have room on the back? I thought you had room on the back. Oh, there's one more example.
Yeah, it's okay.
Lame sauce. But guys, here's the danger. If you just saw this on a test, you would probably think ln of u, right?
Yeah.
And you would say, hey, let's go through and let's make it match ln, then let's go. Now technically, that's not a bad idea, except we need to figure out how to solve these two. Let me think about it tonight. How to actually, what tests we would use. Because right now, everything that we've done has failed.
Epically.
I'm thinking of what test to use. Because it should be both diverge, which means I would have negative 1 to 1. It should be possible to solve. I'm trying to think, is it no, it's not telescoping. It's not geometric. Not nth terms, they both equal 0. P-series, we could compare, but direct comparison doesn't work. I have to think about it. Guys, what's so special about 1 over 1 minus x? What does he get us to?
You know.
Yes.
Mm-hmm. So I can say so I'm trying to find, right? Which equals the integral of, what can I substitute for 1 over 1 minus x? Uh-huh. And I have no constants, right? Dx. So I could go ahead and say ln of 1 minus x is equal to integral of 1. Integral of x. Integral of,
That makes everything so much easier.
Oh, yeah.
right? Because remember, you can take a series, a power series, you can, well, if I integral one side, integral the other side, no big deal, it's a polynomial. So integrate, 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 piece by piece, and I end up with
Yeah. The one we found we have to take in example 10.
So now what? Do we have a geometric series? Not anymore, huh? Because we integrated, so now we have the same problem with the constants. So we don't have a geometric series, but what do we have? Maybe an easier one to use our ratio comparison on, or ratio test with?
Yeah.
Because we don't have that whole one business going on, right? So then we can go ahead and say, all right, let's go back to our ratio test. That wasn't a bad idea, just the one we were trying to do it on was too complicated. This one's been simplified. We need to go back and double check our work. Negative, 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 pull out a negative of all. I still have to think about what went wrong. Anyway, come back. It's easier now. Because now I can go ahead and say, limit as n goes to infinity of x to the n plus 2 over n plus 2 times reciprocal n plus 1 over x to the n plus 1 needs to be less than 1 to converge, right? Then I end up with the limit as n goes to infinity of n plus 1 over n plus 2, once again, are always positive. Don't need to worry about absolute value. And they're going to 1 because degrees are tied. X to the n plus 2 over x to that is x less than 1. We still have the same problem.
Yeah.
Oh,
Actually, those two examples are the same.
can't we just leave -1 less than x?
Because we are.
Well, the radius of convergence, they didn't actually ask us for the interval. Oh, guys, they don't even ask us for the interval of convergence. Lame. But I'm still going to test the endpoints and figure out. Maybe it's impossible. I don't think it's impossible. I'll come back to and I'll look. Test the endpoints. I'm putting a big old star. But the radius is easy because the radius is just what?
That divided by 2.
The distance divided by 2. The radius is 1. Test the endpoints. I still need to figure out. Ethan, you can be thinking about it with me as well.
What does radius of convergence actually mean?
Radius of convergence means half of the distance between the interval of convergence. So the interval of convergence, the distance between these two is 2, and half of that is 1. We don't have to worry about including or not including.
The interval of convergence is
How far between the endpoints of where it converges. So the ratio test, I know that whenever this ratio is less than 1, it will converge. So therefore, in between 1 and -1 is the interval. That's what we've been doing for a while. And then you just take 1 minus -1, which is a distance of 2, and cut it in half.
I'm just trying to think of how that would look like on a graph with
It would like be converging for, it would be diverging for, you could think of maybe like getting smaller to a certain point and then it gets bigger, maybe? I'd have to think about it. It's a good question. Ethan?
Why not use integral test?
Oh, why didn't you say that earlier? That would have been smart. Because integral test, we could have taken integral of, oh, that would have been easy. Then we would have had ln of, pull out a negative, integral of 1 over n plus 1, make u n plus 1, ln of u between 0 and infinity. I would have had ln of infinity minus ln of 0. That wouldn't have worked. Hold on.
That would've made it diverge
ln of n plus 1. That's what we wanted to do though,
though. Yeah.
right? Although it's not geometric series, so we're not for sure that it's diverging. Integral test, u plus 1. Yeah. It's infinity, right? So then diverges. How about the top one? The top one, if I have negative 1 times negative 1 to the n plus 1, that'd be negative n to the n plus 2, right? I could have rewritten that. Because that'd be negative 1 to the 1, 1 plus 1, n plus 2, all over n plus 1. Which I could have just made alternating 1 over n conditionally converges. And so the alternating series would converge, so technically it should be equal to at negative 1 and not equal to at 1. Alternating series converges. What's the second condition of alternating series? The limit as n goes to infinity has to be 0 and?
And a plus 1, an plus 1 bigger than, smaller than an.
Yeah, and n plus 1 would be smaller than. So yeah, conditionally convergent,
Is this one converge?
right? And then diverges by integral test.
So conditioning
I still
convergent,
don't
would
figure
that
out
make
why,
it?
why we got negative in this function.
Why we got negative?
Yeah,
Because you plug in a negative. Because I need 1 minus
because
x.
in the next page, within in the next pages, we're gonna get. If we use integral,
But we also have over 2 over 3 over 4.
yeah,
Do we have it over here?
yeah, but we have negative 1.
I think we're solving this problem.
Confusing.
It is
Just
confusing.
like hiding my hair. I don't know what's going on.
I'll come back. Let me look at it. Kiddos, here's an example of, we're not gonna have time to go over it today, but maybe we will on a day when not lots of people are here or something like that for AP review. But this is example number 12. It's AP, obviously, FRQ. You guys can see, right, the first 4 non-zero, no big deal, general term, hopefully no big deal. Does this series when evaluated at, right? We'd have to plug in to A and then figure out whether or not it converges to. So we have to ask whether or not it's convergent at x equals 1. Letter C, the derivative of arctangent is, right, the first 4 non-zero terms for arctan. Well, how would I go from here to arctan? I could take my Taylor series, and what could I do? Integrate, right?
Yeah.
Yeah.
So I could integrate the Taylor series to get back to arctan, and then part D. It's asking to find a rational number such that is less than 1 over 100. For part D, I think, do we need the Lagrange error bound? No, we don't. Oh, we would plug in. We would take the series from that we got for arctangent, we would plug in 3/4 for x, we would plug in the series, and then we could solve. Possibly. Because if the series converges, and if it converges to a geometric series, which we could write this as 1 minus, right? If I'm trying to find the Taylor, couldn't I use 1 minus x, and couldn't I make it 1 minus a negative x squared? So that'd be a geometric. I could use a radius of convergence. I could find the infinite sum. Anyway, that's the idea of that one. But we need to get on to the Lagrange error bound.
The who?
Lagrange error bound, the new notes. If you guys look at the new notes, it's little, right?
It's
It's tiny.
Why is
Comparatively,
why
anyway.
is his beard like outlined?
Why is his beard like that? I don't know. I think he was made that way. And then he just let it grow.
It's like the diamond attached to his face.
I don't know why.
That's funny.
Because he's silly. I'm going to check something real quick, because in my notes I have the 9.7b, but on the actual packet I have the 9.8b. I just want to have it so that it does correspond to your book. Because, guys, your book does teach these things, but we needed to shortcut it. And as you can tell, some of these problems take a little bit longer.
So is that 910?
Let me look. It's not 9.10, not in our book. I think it's 9.8b.
Lagrange, is that, wait, Lagrange? So he's French. French dude.
9-10 kind of got included in 9-9 because 9-10 was using them to transform. Is it not 7? Does our book even teach Lagrange? Taylor polynomials. It'd be 9-7b. You guys can change it. It'd be 9-7b.
It says 9-7B.
Yeah, but not in your worksheet. It says 9-8b.
That's MD stuff.
That's my bad. And then the chapter 9n just kind of is like all of chapter 9. Chapter 9b. Chapter 9b. Not convergence, divergence specifically. Kiddos, going back to Taylor polynomials. Remember, Taylor polynomials approximated, right? And if they approximated, that means technically there was some error, right?
Yes.
There was some error. It means that it wasn't plus dot dot dot. It wasn't the infinite sum. So we weren't dealing with convergence or divergence necessarily. We were dealing with approximations. That's why there's R sub n, T sub n. R sub n we already talked about earlier this year. That notation is used for remainder, right? Remainder, or we could say remainder or the error. What remains when you subtract the actual and the approximate?
I think I have a book.
T sub n is the nth degree Taylor polynomial, which we already know from before. F of x is my actual function. And this is my n plus first term. Now we know this from, which we could write as this is technically just kind of like a reworking of the remainder theorem from alternating series, right? Oh, I didn't label. I said it, I just didn't label it. Actual function. Okay. For an nth degree Taylor polynomial, R sub n of x, or the error, is given by. The remainder is going to equal the n plus first term. Wait, equal. What did we talk about before? Less than, right? First of all, make this endeavor number, where are we on, 29?
I think so.
It's our special Maclaurin. Our special Maclaurin were 28. Z. Do you guys see a Z? That's the difference. Z. Z is interpreted to be an x value on, let me zoom in. I'm going to put in little quotation marks, which might help us understand it a little bit better. Lagrange error bound basically tells us the worst case scenario in the sense of how bad our error could get. And that might make some sense with z being the value that maximizes the n plus first derivative of f. That maximizes the f to the derivative or the n plus first derivative of x. So maximizes, this is like my maximum error. So it's like the worst case scenario in the sense of, you can think of the maximize, that's why it's called an error bound, but it's the maximum. Now the AP guys, I don't think they're ever going to ask you to maximize the error, but they are going to mention the Lagrange error bound. And so it's kind of just understanding what it is. So the nice thing is we don't really have tons of craziness to memorize, because it is our n plus first term, which means if we stop at n, it's going to be the next derivative of f, it's going to be the n plus first factorial, it's going to be to the n plus first power. But I have this new z. So what do I do with it? All right. Let's start at the beginning. Let f be a function with 5 derivatives on the interval 2 to 3. Assume that the fifth derivative of f of x, absolute value, is less than 0.2 for all x in the interval 2 to 3. And at a fourth degree, wait, why are they telling me about a fifth derivative if I'm looking at a fourth degree polynomial?
N plus 1.
Because it's the n plus 1, right? The error is going to be less than the n plus 1th derivative. Okay, well, the n plus 1th term. So a fourth degree polynomial for f at c equals 2 is used to estimate f of 3. How accurate? What are they asking when they say how accurate? Yeah. What is the error bounded by? So how close is it? But to show how close it is, I have to show how far off it could be, right? Okay, so then, Taylor polynomial and error. Whenever we think Taylor polynomial and error, let's look at basically the Lagrange error bound that you guys just saw. Okay? So if I want to find my fourth degree, right? I could go ahead and say, just filling into the Lagrange error bound, I could say it's t sub 4 of x minus actual f of x. They didn't tell me what it is, so I can't say what it is either. An approximation is only as accurate as the maximum of its error, or its possible error, right? So I'm going to go ahead and find, well, if it's a fourth degree, I'm going to need the fifth degree derivative, right? So I'm going to need the fifth all over the fifth, n plus 1, right? Factorial times x minus c to the fifth power. That's the general, using Lagrange error bound. Just plugging in. Just plugging in. Assume that, okay, they gave me a few different things, right? I have this. I have estimating f of 3. How can I use those then? What's my x if I'm estimating f of 3?
That first part there is, never mind.
No, you're right. I'm estimating 3, I'm estimating 3, I'm estimating 3. That helps a little bit, right? Then how do I use my other clue? What is the fifth derivative of f bounded by? What is the maximum that could be? I wouldn't even necessarily say could be, but what's the maximum value? 0.2. And then I would plug and chug. 3 minus 2 is obviously 1. 1 to the fifth is what it is. 2 is 1/10. 1/10 times 5 factorial ends up with, I have an error bound of I put before, I'm going to put plus or minus. Or another way of saying it is we could say, maybe this would be an easier way, if you don't like the plus or minus that randomly came out of nowhere. Absolute value is going to be equal to, so we could say absolute value, then it has to be within 0.0016. That's another way of saying it, because then my absolute value would equal. And as we know, absolute value can be positive or negative, so it can be up that or down that. They say give 3 decimal places. I gave 4. I guess 3 technically would be 0.002, right? You can't get mad at me for doing too many. Suppose that the 4th degree polynomial of 3 is equal to 1.763. Use your answer to find an interval in which f of 3 must reside. Well, then we just have to apply, guys. If the error bound is within 0.0016, what do I do with my polynomial approximation?
Plus and minus.
Yeah. Couldn't I think then, if the absolute value is going to be equal to 0.0 or within, then couldn't I then say, okay, positive and negative? So I can subtract 1.763, divide by a negative. Long story short, you're just going to be taking 0.0016, adding and subtracting, right? So I'm going to get f of 3 is in between. I already did it. What is it? .7613 and 1.76466. To be accurate, I'm going to go ahead. I think I changed it to 2 at the next problem. So you can subtract, you can add. Mm-mm. Okay. That's not possible, right? Could f of 3 equal 1.764? Yeah, of course, right? So just kind of making you think through like what it actually means as to what our values could be and how close our approximation is and this, that, and the other. Now, in this one, the example didn't actually state Lagrange error bound, but that's what we were supposed to use, right? Because we were trying to maximize our error. We're only as accurate as our maximum error. What does example 2 do? Maximum error, there it is. They didn't actually say it, but once again, what are we going to have to use? The Lagrange, right? But the nice thing is it's a Maclaurin, so we don't even have to do any work, right? So it would be our approximation. We got it. Sine has what kind of symmetry?
Odd.
Odd, right? So I'm going to have x minus 5th degree, right?
Yeah.
What does 5th degree mean?
And is
Fifth
it
term.
5?
Is n equal to 5?
No, you have to.
Or do I go up to the 5th derivative? Do I need 5 terms or do I get to stop?
Derivative.
Yeah, I get to stop, right? Because I've gotten up to the 5th degree. So we don't have to go any further.
So NBC go back.
Yeah. Because 0 plus 0 plus 0? No. You said 0. Ethan, I know sine of 1 isn't 0. But I would plug in 1, right? So I'd have 1 cubed over 3 plus 1/5. And then I'd have to use, we can say Taylor's theorem really is the Lagrange error bound is what it actually defines. Good news is we're finishing this on Monday, which means test on Tuesday. Will probably not happen. It'll be test on Wednesday. I can't even talk, guys.
I was like, that was a big jump.
Test is on Wednesday. With this though, hold on real quick. Tomorrow is Pi Day.
Oh.
Ultimate Pi Day, because it's March 14th, 2015. If you take a picture of yourself at 9:26, why?
Because then it'd be
3.1415926. If you take a picture of yourself with a digital, like it could be your phone or someone else's phone showing 9:26 tomorrow, and email it to me by midnight, you get extra credit.
9:28.
And then Monday at lunch, we're gonna have a pizza celebration in the gym. You have to buy pizza, but if you bring circular dessert, you get extra credit like last year. So, Phil Kaiki. Yeah, possible. So photo challenge tomorrow.
What if I was that?
I'll count it. I'll count it. You just have to bring in one.
Like one.
Miss
So it's
G,
just on Monday, guys.
we celebrated Pi
So
Day.
you going to CHL?
Yeah. Taking pictures. We can do. I was thinking of doing it on like the Snapchat thing, because you know like how they have the clock.
No, you're okay.
Is it okay if Layla and I take the same selfie?
So it would be the same, it would both be negative, and then we have to. Thank you, Ethan.
Layla and I will both be at CHS in the morning, so those of you both take like the same selfie. And then-
Totally.
Yes.
Just send it and have both your faces in it. I'll count it.
But don't hit your head. You were like right under the desk. Are you okay?
Oh, Layla, hi.
Grab the other hand too. Be crazy. Are you okay? You gotta work. You gotta work on your grace here. I went to grab the other hand and he wouldn't grab it. Yeah, he was just like, this is not secure. Poor Layla.
My mom came in at like 8:40. I was like, you going to